Hi, I'm Brittany. I'm a senior application engineer with ESP International. And today we're going to talk about design for manufacturability and design for manufacturability repeatability, known as DFM or DFMR. A couple of things we're going to discuss within this small presentation is what is DFM? We're going to also talk about why DFM is important and should be integrated in your design phase. We're going to talk about how you should integrate it when looking at different applications and reviewing from an engineering development standpoint. And we're going to talk about when and where within your process you should consider DFM. So first off, what is DFM? Design for manufacturability, repeatability, sole and purpose is when you're looking at a drawing or some sort of applications parameters that says, hey, I need to build something custom, something that is unique to your everyday catalog or COTS items. You're going to have to ask yourself, what are some key characteristics or areas within a process that may cause you to consider DFM? In terms of how can I ease TAT time? How can I, and TAT time meaning, let me clarify, turnaround time. TAT time for operations. How do I ease the production life cycle? But first you kind of need to understand what phases of your product goes through the design review phase. So first we have here where a new bid. Your sales guys or anybody come in, they say, hey, I got a great new opportunity. Let's look at this product. Let's go ahead and work with engineering and design it. You're going to say, well, let's look at the application. Let's figure out what kind of concept design we want to go with. Once you figure that out and you identify that, you go into samples usually. Typically, that's kind of how that goes. Within the samples, customer tested, they spec out, they work great. You go ahead and you release it to production. With releasing it into production, you say, hey, we're all set, we're ready to go. But there's instances in some cases in which what you've designed in theory, right, behind closed doors and you tested and validated, may not be applicable, right? You might run into some shortcomings on the line. They can't actually build it. They have some issues. You might get it to the customer. Somebody else is testing it and looking at it on a day-to-day application. You say, why did my samples work very well, but now that I'm in production, I'm having some issues? This is when you should consider design for manufacturability. However, now you're kind of saying, well, how do I get that at the front end of the business phase? Because now I'm only talking about DFM after I've got a known issue, a known problem, right? So you want to start looking at what is important. Process, design, material, environment, and compliance testing. So let's start with process. What is the process that product is going to undergo? Where are you buying it from? Where's your raw stock, materials, etc.? Where are they coming from, your supplier, your OEM and manufacturing? How are they going to get shipped to you, etc.? The design, the application, how is it going to be installed? We talked about how it works functionally, but what about installation parameters, right? Who's all going to see it? What about the additives in terms of material? Is there additional finish? Is that finish that's going to be put on that material going to be impacted in shipping and handling? Some other things to consider would be the environment, right? DFM may not apply into the environment standpoint on the direct product, but maybe the storage and the conditions in which that raw material before you go to construct your assembly or to construct your component part. Maybe that might take a factor into it. So thinking about how it's going to be stored, or maybe the end application use. Maybe that product gets made and it works very well on the line, but then you get it and it gets to the customer and it sits in their hangar or their storage location that's exposed to different ozone and environmental conditions that may cause your parts to, from a rubber standpoint, degrade a little bit quicker than it should. Or from a material standpoint, if it's in the rain or something or in a moist environment, corrode, right? So you got to think about the environment as well as compliance testing. Compliance testing is not limited to how this part is performing actually on the line, right? So what I mean is that functional test that you're doing in the manufacturing environment to send it to the customer. Compliance testing might also be rigorous testing, testing to failure, testing to end of life, etc. You're going to want a product that can do all of these different things throughout its product's life cycle. So we talked about what, right? So who are the key stakeholders? I think it's kind of obvious to know that it's going to be operations, right? Turnaround time, because after you put this into production, these guys are the ones that take the biggest hit, right? When we kind of talked about, hey, well, we understand that at the end, we're seeing a lot of issues, but when is it important? At this phase, you should be talking about DFM. How do I start talking about DFM? Who do I need to talk to? You want to start working with your quality team, operations, supply chain. If you were the product from start to finish, what hands and departments are you going to go through? The biggest question you need to answer, and it's kind of, not something that typical engineers look at, but the non-conformance. What I mean by non-conformance, and it's more of a quality term, but it's related to engineering. And the reason being is there any handoff between departments or different life cycle studies that this non-conformance or a defect is going to happen to my part? And one big misunderstanding is that shipping and handling is not typically a part of the design review phase. And that's because, hey, I designed it, it works functionally, it went out there. So who cares how it's shipped or packaged? But if it's getting damaged in your UPS or your freight or anything of that nature, that could actually impact your product. That impacts lead time, you have damaged parts, etc. So the end goal and the end focus is, why is this so important? Why should I consider it? Because you want to limit that cost to quality downstream. And that cost to quality could be anything that can impact the performance and the quality of your product, which comes into design for manufacturability, which impacts operations. And this is why it's important for us to consider these type of things prior to sampling and production. So then that way you can ease the process life of this product through its cycle. So hopefully I answered all your questions. Goodbye for now.